Hi guys, it's Joe here at Measurement Solutions, and today we're going to look at some assembly optimization in nTopology. So to start with, we're going to need a CAD model. We've imported this step file into nTopology. It's 3 separate CAD bodies that build up this bracket. So we're going to convert it into an implicit body. We're going to set some restraint faces, a load face, and a passive region that we want to make sure is kept during the topology optimization. So we're going to convert the whole region into a design space. We're going to mesh it and use those faces that we set up earlier for the force, the restraint, and passive regions. We've set up our boundary conditions and we're going to run our topology optimization. So we can see the raw result of the topology optimization here. We've got some kind of quite steppy and jagged faces, as we'd expect from a raw topology optimized model. But in nTopology, we can really quickly smoothen this to give us the final result using implicit bodies. So here is our final part. It's been smoothened and it has our interface regions booleaned back into it. Now, the beauty of this is that we haven't just created a model, we have created an entire workflow. And in this particular workflow, we set up some inputs and some outputs so that we can use it as a custom block. So now we've set up a new instance of nTopology. I'm going to import in the CAD model and the custom block. So everything we saw in the last workflow is now combined into this neat little custom block here. And all the custom block is asking us for is for an implicit body. So we're going to set this up now. It's asking us for our restraint faces. So I'm going to use those same restraint faces that we used for the last optimization. It's asking us for a load face. Again, we're going to use this hole. And it's asking us for some passive regions. So we're going to use this dome again for those passive regions. Now in the background, nTopology is working away to create this custom block for us. So it's going to create a mesh of the design space. It's going to apply our restraint faces, our load faces, and our passive regions to create the topology optimized result. It's going to smoothen it, boolean it back with the interface regions that we want to keep, and create a boolean intersect to make sure that there's no material outside of the original design space that we set. Now this process is going to take around a minute to complete. There are some quite complex operations going on in the background, but nTop is still able to do those really quickly. So we're going to hit fast forward on this, whiz through to our final results. And here is the final result of that optimization. The topology optimized bracket that's now been converted from 3 separate parts into one topology optimized shape. And we've packaged this up in a nice neat custom block. So if we have a series of parts that we want to do a very similar optimization on, or if someone else within the business wants to do a topology optimization of their own, then we can share this custom block and use it over and over again for all sorts of different models. So hopefully you found that video interesting. If you've got any questions on this particular workflow or any other nTopology queries in general, then please feel free to give me a shout. Cheers.